Welcome to Three Inquisitive Kids. In this video, we're going to be learning about converting multiple-digit repeating decimals into fractions. So here's our first decimal we're going to be converting, and it's 0.363636 and so on and repeating. So, what is our first step? Well, I'm first going to just set x as 3.363636, and you might think, well, isn't that kind of making the bit more confusing? Well, I'm going to be doing this just for the sake of solving this problem. So since this is repeating, just, so on, and it keeps going. Now what we're going to do is we're going to find the spot where one repeating round stops, which is right over here. And then we're going to move this decimal point over there. And how do we do that? Well, we can multiply 100 on both sides. So on the left side is 100x, and on the right side we have 36.363636, and so on. Now, I want you to pause and ask yourself, is this correct? Well, we already just made a variable that said x is equal to this whole thing, and then we multiplied 100 on both sides, so the decimal point just starts later. Now what we're going to do is we're going to try to get rid of this hard terminating part. What do? Well, you see, when we set x as this decimal right here, it was we could find x that way. We can find x in another way. So what I'm going to do now is I'm going to subtract 1x from both sides. So over here, there's 100x, and I subtract 1x, so we get 99x. And that's on the left side. On the right side, we do this whole thing minus this part. Well, you might think, well, it keeps going on forever. There's no way we can do the subtraction. Well, behind the decimal point is still the same, right? Because it goes on infinitely. So we can subtract the repeating parts, which is the 36 behind, sorry, not 36, the 3 sixes behind the decimal point. Then we'll just get 36. This whole thing crosses out because we know that x is equal to this, and we subtracted x on both sides. So yeah, now we're going to try to solve for x. Well, you probably know this. 99x is equal to 36. We divide a 99 on both sides. So that leaves us with x is equal to 36/99. There, we solved the problem. We turned x right here into a fraction. And actually, we can simplify this fraction by, well, we know that both sides we could divide a 3. We can still divide a 3. So now we have 4/11. And that is the answer. 4/11 for the first problem. Let's first just quickly go over what we did right here. So we set x as 3.3636 repeating, then we multiplied 100 on both sides so that we could move the decimal place backwards a bit to make it easier for the next few steps. Then on both sides we subtracted the x, which on the left side we have 99x, and on the right side the repeating parts canceled out, and then there was 36. Then we solved for x by dividing 99 on both sides, and then that was 36/99, but we could simplify that, and we got 4/11, so that's our answer. Now, let's go to the second problem, and right here, I want you to take what we learned from the last problem, and I want you to first try doing this problem yourself. Then we're going to come back and we'll go over it together. What's your answer? So we're going to So right here, we're going to do the exact same steps as last time, and by the end of this, I hope you're going to be stronger with the, you're going to become stronger with using this method. So let's get started. X this time, you know what, I'll do it as A. Okay, A. A right here is equal to 0.545454 and so on. Well, let me ask you, what is the point where the first repeating section stops? Right here, because then it goes back to the 5 and keeps repeating 5, 4, 5, 4, 5, 4. Then we're gonna try to move this decimal place right here to this marking. What do? Well, we multiply both sides by 100. Remember, with other problems, you might need to multiply 1,000, a 10. There's many different ways. Now for this one, we're gonna multiply 100 on both sides, so we have 100a on the left side, and on the right side we have 54.545454, and so on. 1, 2, 3. Now we're going to subtract 1a from both sides. On the left side we have 99a, and on the right side we have 54.545454 minus 0.545454. These two parts cancel out, and we just have a 54. Now we solve for a. A is equal to 54 over 99, and we can simplify this because we know that there's a 9 on both sides, and that's equal to 6 over 11. Now let me ask you a question. What pattern can you see from the answers? Let me write this bigger. The answers from each of these problems. Well, I know for these two special problems, they both have a denominator of 11. But what about this part? Is there something special? Like over here, we had 36 over 99. And down here, we had 54 over 99. Doesn't it seem like the denominator is always 99, except that the top is just the repeating decimals? Seems like it. Let's keep going. So right here again, I want you to try solving this on your own. I want you to try. All done? Let's get started. So we first set x. You know what? Now I'll do a z. So z is equal to 0.187187 and 187. Keep going on and on forever. Then let me ask you, when does the first round repeating stop? Right here, because then it goes back to 1. Well, we want to move the decimal point over here, so we'll multiply 1,000 on both sides. On the left side we have 1,000z, and on the right side we have 187.187, and it keeps going so on. Now we subtract 1z from both sides. So on the left side we have 999z, and on the right side we subtract this part from this part, and these two repeating decimals cancel out, so we have 187. Notice how much 9's are here now. Then we solve for z by dividing 999 on both sides, 187 over 999. And there, that is our answer. Z is equal to 107 over 999. This time, you see that the answer now it isn't just 2 nines, 99. It's 999. Right now I'm wondering, why did it change? What made it change? And does it have some sort of relationship between how much digits there are repeating? Well, you might have seen that there's 3 nines because there's 3 places repeating. And why is this so? Because over here we had to do 1,000 to get this decimal place over here. So once we subtracted that z, it always went down into 999 or 99 if it was 100. That's the pattern. This time we have a slightly different type of problem. 3.5 with 41 repeating. How can you do this problem? Well, one way is to split it up as 3.5 plus 0.041 and then do it that way. But there's also another way. First, we said this is a variable just as any other problem. This time I'll make it, let's make it m. So m is equal to 3.5414141 repeating on and on. Now, what do we do? The first question you ask yourself is, how much digits are repeating? How much digits are repeating in the decimal? Well, in this case, there are, count them, 1, 2, 2. So there are 2 digits repeating, 2 digits. If there's 2 digits, then we do 10 squared, and we're going to multiply each squared 10 squared with 10 squared. That's the same to as 100. So we're gonna multiply both sides with 100. So on the left side is 100m, and on the right side we have 304.141414, and so on. Now we're actually going to subtract the first equation from the second, which is basically subtracting a m on both sides. If we do that on the left side, we'll have 99m is equal to, well, let's put this aside for now. What is 354.141414 and so on minus 3.5414141 and so on? Well, this back part right here all cancels out, so we now just have this front part. Well, this should be easy. We get 350.6 in the end. So 350.6, and I can delete this part. Anyway, now we have this. We solve for m. M is equal to, we divided 99 on both sides, 350.6 above 99, which is also equal to, we don't really like decimals, so we can times a 10 on both sides, which is 3,506 over 990. So there it is, our answer. 3.541 repeating is equal to 3,506 over 999. Sorry, 990. What do we do in this problem? We ask a really important question. How much digits are repeating this decimal? Well, there's two digits. So we multiply both sides with 10 to the power of 2. But remember, if there was 3-digit repeating, it would be 10 to the 3, 10 to the 4th powers. And then we, as usual, we subtracted 1m on both sides, which then we could solve for m with 350.6 over 99 or 3,506 over 990.